to do the classification of system based on impulse response. Okay, so if the impulse response of a system is given, okay, so if the impulse response of a system is given, so generally we are going to classify the system, and this system belongs to a special category, that is LTI. Okay, because LTI system, I mean, though every kind of system is going to have impulse response, but we represent uh, LTI system by impulse response only. Okay, for rest of the system, we don't really use impulse response as frequently as we do it for LTI system. So we will, given a LTI system and its impulse response, we will try to classify it. Okay, whether it is causal or not, whether it is, so given a impulse response, so let's say HT is given, and based on this HT impulse response, we are going to classify the system, whether it is a causal system, and a non-causal, and then based on HT only, we will classify the system based on whether it is stable and unstable, and third category is whether it is instantaneous or dynamic. Okay, we are not going to classify into linear or time invariant, because we are already assuming that the system is linear time invariant. So we are going to do these three things. Okay, so under what condition we call a system to be causal? So let's discuss this causality first. Okay, so under what condition we say that a system is causal? If output depends on upon
Present or
present and
passing.
past, right? Okay, so basically we have to find out what is yt, and yt of the system will be given by ht and convolve with some input xt, right? And this will be written like this. I mean, we already know that this is minus infinity to infinity x of t h of t minus tau, isn't it? It is like that. And I mean, it's much easier to see this in discrete time, so I will be doing that only. So output y of n will pan in the same manner, and that is k equal to minus infinity to infinity convolution of x of k h of n minus k, like that, isn't it? This is how it will be written. Is that clear? So this is convolution sum. And if you expand this, what does this mean? You are multiplying x of 0 h of what n, isn't it? And then after that you are on this side, let me take x of 1, and you will have h of n minus n plus 1, isn't it? Similarly, in this direction it will move on. So here you will be getting x of 1, h of x of 2, and h of n plus 2, right? And before, if you proceed from 0 to minus infinity, then you will be getting x of minus 1 times h of n, uh,
Oh,
sorry,
minus there, no?
it
Because
should be
of
here minus 1, right? Sorry, sir,
yes, sir.
just wait for a minute. Let me expand this, and then we will see. So we always remember the result, but we have to express it properly. So here you can write x of 0 and h of n, right? And when you are going to have x of 1, it is going to be h of n minus 1, isn't it? Right? And then you will have x of 2, and it is going to be h of n minus 2. Similarly, on this side, what we are going to have x of minus 1 h of n plus 1, isn't it? Right? And then this is going to continue all the way. So let me write the continuity equation here. And minus 2 will be multiplied with h of n plus 2. Right? Something like this. And this is going to continue in this direction as well. Now, what is this system is causal. We are assuming that this system is causal. Then what should happen? It should depend upon x of 0. It should depend upon x of minus 1, isn't it? Hannah, is it
Yes.
clear to all of you? Okay. So for this, what should happen? H of n minus 1 must be equal to 0. Okay. This is a bit, I have written it like this, but let me just again try to attempt to write this. So I can write this equation here like this as well. So this can be written as k equal to minus infinity to plus infinity, and then instead of x of k you can take h of k and then x of n minus k. Okay, from there this equation will be much more visible. Okay, so this will be equal to what? H of 0. So this is going to be equal to h of 0 times x of n, and then you will have h of 1 and x of n minus 1. You will have h of 2 and you will have x of n minus 2, right? And then it will go on in this direction, and in this direction you will have h of minus 1 and x of n plus 1, isn't it? And here you will have h of minus 2 and x of n plus 2, right? And this is what, this is basically our y of n. Now y of n should depend upon what? It should depend upon x of n, x of n minus 1, x of n minus 2, and it should not depend upon this, right? It should not depend upon this x of n plus 1 and n plus 2, because these are the future values, isn't it? Can we agree on this, that it should depend upon n minus 1, n minus 2, x of n,
Yes.
but it should not depend upon x of n plus 1, x 2, and so on. So future value पे depend नहीं करना चाहिए. Now we don't really have any control over our input. So what we have control over is impulse response. So how can we nullify the effect of x of n plus 1? By making all these h of minus 1, h of minus 2 equal to 0, isn't it? Right? So for causal system, this h of n should equal to 0 for n less than equal to 0. Oh, sorry, less than 0, not equal to 0, and less than 0. Okay? So given an impulse response, you can always determine whether it is causal or not, depending upon whether its impulse response is causal or not. And this is the definition of causal signal as well, that causal signals are 0 before t is equal to 0. Okay? So similarly for continuous time system, h of t should be equal to 0 for t less than 0. So this is the definition of causality here in terms of impulse response. Okay. Next we are going to see stability. Again, as I talk to you about, we will be discussing BI/BO stability. So let me just write that only. BI/BO stability, and for a BI/BO stable system, output must be finite. So y of t should be. Let me just write this. What is the definition that we discussed, that we learned about this in terms of input and output, that if x of t, a mod of x of t is less than some value, let's say uh, mx, and that is less than infinity, then output y of t also be bounded by some value. So let me write this m of y less than infinity, right? And in terms of impulse response, our output is related to input like this, that it is minus infinity to infinity x of tau h of t minus tau d tau. And for a stable system, this y of t, mod of y of t should be less than infinity when xt is less than infinity, right? If x of t is less than infinity, isn't it? So we will apply mod here in this equation, and we will be arriving at this, that mod of yt will be equal to minus infinity to infinity mod of x tau, right, into mod of h of t minus tau and d tau. Okay, or we can write it like this, that minus infinity to infinity x tau, mod of x tau, mod of x of t minus tau and d tau. Okay, and this value has to be less than infinity, isn't it? Now we already know that this x of t minus tau is less than equal to some constant. So this value I can write from here, that this mod of yt, sorry, y of t will be less than equal to, put its values, that is, let's say m of x, isn't it? So it will always be less than m of x times mod of ht and d tau, and that is less than infinity, isn't it? So from here we can see that this value minus infinity to infinity, absolute value of h of tau d tau is less than infinity. Okay, for a stable system, the absolute value of impulse response should be less than infinity. Okay, should be some finite value. Is this clear to everyone?
Yes, sir.
And this is, right here is the reason why none of the, what you can say, ideal system are stable. Okay, so if you learn about ideal system later, for example, ideal low pass filter or ideal high pass filter or band pass filter, okay, all of them are unstable. Okay, the reason is that their impulse response is basically sinc function or shifted version of sinc function. Okay, impulse response of, we will learn about that later in detail after learning Fourier transform and all that, but there you will learn that their impulse response is basically uh, sinc function, and sinc function is not absolutely integrable. It is integrable, but it is not absolutely integrable. So सिंक फंक्शन आपने पढ़ा होगा, जो वीडियो दिया था तो उसमें देखा होगा कि साइन ऑफ, अगर इफ यू आर taking normalized sink, that is sine of pi t divided by pi t, so its area under curve is equal to 1. When it is square integrable, means square कर दो सिंक को और इंटीग्रेट करो तो भी 1 ही होता है. But if you take its absolute value and if you try to integrate that, that is infinity. Okay, and actually proving that is very difficult. Okay, it requires a lot of knowledge of higher mathematics, but uh, you can take my word that impulse is not absolutely integrable. It is the only, it is one of those functions which is integrable, which is square integrable, but not absolutely integrable, and that's why all the ideal system are going to be unstable. Okay, so this is how we are going to check that. Is this clear to everyone? So this is the again, let me just write down the value of instantaneous system only, and then from there we will move on. So instantaneous system, and then that can be looked at from causal only. Okay? So here in causality you can see that this y of n should depend upon x of n for instantaneous system. It should not depend upon h of minus 1 or h of 1, isn't it?
Hello, sir. So you are not audible.
Hello guys, am I audible? Hello?
Yes, sir.
Actually,
Yes,
I'm
sir.
unable to join through my computer now. Okay, my network is not working properly. Yeah, I tried to reconnect it with my mobile, but I'm unable to connect through my mobile network for some weird reason. I don't know why. Let's my actually the balance that we had that I have is not working at the moment. So I think I will not be able to conduct this lecture as of now. We will try to do this up on Friday. Okay? Sorry for the inconvenience. I'm trying this, but I'm unable to join. Okay. So I'm going to end this session now, and आप लोगों को मैं फ्राइडे में शेड्यूल कर दूंगा लेक्चर, क्योंकि अभी मैं ज्वाइन ही नहीं कर पा रहा हूँ कंप्यूटर से.
सर
हाँ बोलिए.
सर क्या आप वो सिंक फंक्शन वाली लिंक शेयर कर देंगे?
सॉरी, क्या किस चीज की?
Yes, sir.
सिंक फंक्शन
सिंक फंक्शन का ऑलरेडी टीम में ही किया है, बट वहां से मैं राज को बोलता हूँ, उसी का लिंक है तो वो शेयर कर देगा आप लोगों को. ठीक है. ओके. मेरी आवाज आ रही है आप लोगों को?
Yes,
Yes,
sir.
sir.
Okay. So I'm going to actually I'm unable to end the session in fact, since I cannot join through my computer, I'm unable to do that. So all of you can leave now because I will not be able to conduct this lecture because I'm unable to connect through what you can say computer. Okay. तो वेदांत हम लोग फ्राइडे को मैं शेड्यूल कर देता हूँ और वो लिंक जो है वीडियो का वो टीम में ही अवेलेबल है, यू कैन चेक दैट, बट आई विल आस्क राज अगेन टू शेयर दैट लिंक. ओके
Yes, sir.
ठीक है, तो मैं अपनी तरफ से एंड तो मैं कर नहीं पा रहा हूँ, सो आई एम गोइंग टू
Sir, recording stop हो
okay. I think when everybody will leave, it will automatically going to be let me just check it once again whether I'm okay, sorry for that. So I will be able to end this now. मैं इसको end कर सकता हूँ, आप लोग जा सकते हैं. Okay, I'm going to, when I will end this, it's going to terminate the recording as well. I
Thank you,
think
sir.